Okay, so you look on the you look into the wireless router. It's the same with the router in the home, right? So when click on this one, basically in the home router, you just plug in the cable. You go to the 192.168.1.0 and you enter the password and username, and by the default it's the admin here, right? So for this one here, when you go to the setup of the wireless access point, you have something, right? The first thing is that you can work with the DHCP. So we see in the DHCP, you have the IP address for this one here, 192.168.5.1. That is the IP address of the home router. It also is the IP address of the gateway, right? So we see that if think about if you connect to the street for this one, and you connect to the street, and you connect it to the, sorry, this one we have, what is it, what here? And the thing about this one, you have to connect it to the street, and you connect it to many other router, and they connect it to the street here. Okay. What is it? Let me see. Yeah. This one is not. This one here. Sorry, I had to delete it. Okay, so now the thing, that's one. When you go to the interface of the router, right? You have the option here. The first thing that is the gateway information. So for every computer in the network, if you connect to the wireless access point here, you have to configure it with the same default gateway is 192.168.1.5.1, right? Because it is the only way you go to the internet, you go out to the outer network here. That's the first thing. The second thing here for the home router, also we have the option for the DHCP here. The DHCP server option. DHCP server is a dynamic port compression protocol. That means you are able to get the IP address automatically from the home router. You don't have to manually configure, right? So basically, if you manually configure, you have to go with static here, right? You have to go with static here, and you have to manually to enter what is the IP address, what is the subnet mask, and what is the default gateway, right? But when you activate the DHCP here, you can get it automatically from the home router. And you see in the home router, you have some option here, right? You have the subnet mask. That means you have support for the Class C network here. Also, you're able to set what is the start IP address. It depends on you. You can send something about if you want to set it from 50 here. It's totally depend on you, right? And if you want to set, you change it to a limit to the 20 user here only. You can do it. You can do it here, right? So that is when you configure with the DHCP, and you see by the also you can decide what is the list time, right? By the packet chaser, you are not able to change it, but in the real router you can change it here. So that is the first one, right? That is the first one when you configure with the home router here. Now we go to the wireless. So we see in the wireless you have some option here, right? So what is the band you want to do it? You remember that when you study about the wireless here, you have the two major bands. What are they? Any idea? You remember it? You have the two frequency bands here. What are they?
Wasn't it like 2.4 gigahertz and 5 gigahertz?
Yes, right. You have two ranges for the wireless. It is 2.4 and the 5 here. So it depends on the router, but mostly nowadays the nowadays router, they support both of the 2.4 and 5, right? So that's why you configure the mix here. Now you configure for the network name. The network name is something when you scan the wireless, like you can see what is a wireless network. So think about when you go to the IB Tech campus, you can see you have the IB guest or IB staff, something like that, right? That is the network name here. So you are able to configure the network name, right? Also the radio band here, it's up to you. You can set it, the radio band is a standard or 20 or 20 here. And the channel, you have the auto for this one, standard channel, and you want to broadcast it or not, right? So if you click at the broadcast, that means when the sorry. Okay, and the broadcast, that means when you scan, when you have the cell phone, right? You scan it, you can see what is a network ID here, what is the network name, or if you want to disable it, you have the option to do it here, right? So basically, that is the basic wireless here. You are able to configure for the home router. Now you move to the wireless security here. So in the wireless security, you have some of the option. You can disable it. You don't need any security here, or you can have web or WPA personal, WPA enterprise, WPA personal 2, and WPA 2 enterprise here. So I believe that on last class I already explained what is a WEP and what's the WPA, right? So basically, these two guys here, it is not very secure now. That's why nowadays they don't use it anymore. They don't use the WEP and they don't use the WPA anymore, and WPA enterprise anymore. And mostly nowadays they work with the WPA 2 personal and WPA 2 enterprise here. So what is the difference between the WPA 2 personal and WPA 2 enterprise? What do you think? What do you think? What is the difference here? What is the difference between the WPA personal and WPA enterprise?
I think personal is better because didn't we get rid of the RAID thing earlier or something?
Okay. So now let me tell you here something here. Okay, so basically, right, you see that if you work as a personal, you have the home router here or home access point here, and you have the cell phone or laptop, everything. So when you work with the personal, you only able to configure for the one password only. I see everyone have share the same password. You think about you can think about the home router, right? So when we set the password, for the home router, everyone here share the same password. So basically, it's only work with a small network only. It's not good security for the huge network. You can think about if you have the network of 100 or 1,000 users here, it's not good security practice if everyone share the same password, right? It makes sense. Okay, and one more thing about personal and enterprise is that you can think about in the case of enterprise here, you have the network, you have many router, you have many switch, you have many firewall here. So basically, if you have to configure the password for every single user here, you have to log into every single router, every single firewall, and every single switch. You configure for the router for 100 user or 1,000 user here. It's not good, right? It's not good here. So basically, for the enterprise, they have the dedicated server. They call it radius server here, radius, or they call it AAA server. AAA is accounting, authentication, and authorization. Right? So in the enterprise, whenever you log into the router or the switch, it asks what is the username and what is the password. Right? So when you enter the password and username, it routes it to the dedicated server here. And dedicated server, they have the database of everything about username and password. And remember, each of you have different username and password here. Right? So this one here, the control every device in the network. So whenever you log in from this one or log in from this one, you use the same username and password, and it route to the database here. So it's more secure. The first thing is more secure. Each of you have the different username and password. That's the first thing. The second thing is that it controls centralized control. So you don't have to configure username and password on every single router or the switch here. You just need to maintain the database in the dedicated server here. It makes sense? Hello?
Yeah, it makes sense.
Okay. Now come back to this one. Right? So basically for this one, you work with the home router. So basically you only have option with the personal here. So now we see when you're done with the home router, when you're done with the home router configuration, right? Now the laptop is still not able to configure it to, the laptop still not able to connect to the home router here. So what is the problem? When we click on the on the laptop here, right? What is it? Okay, so I have a config here. So now we see you already set you have something here. You already set the network name, right? You already set the password here, and you already set the security here. You have to make sure that all of the information you config in the laptop match with the thing you config in the wireless router, right? So for this one here, you have wireless here, right? The first thing here, you see, you are not able to connect it to the home router because the network name here is not the same, right? So see, in the network here, you configure what is the network name for this one. You have here the network name here, right? So you have to configure it exactly the same in the laptop here. And the second one, the network plus here, correct, right? Because you see the network plus here. Now, correct, right? So the third one, what is the third one here? Encryption type also, right? In the encryption type, you have the two type of encryption. You have AES and TKIP here. And AES, I explained it on the class. It's more secure than TKIP, right? So see, in the router here, you work with the AES. So that's why in the laptop also, you also have to configure with the AES here. So now you see, you are able to connect to the router here, right? And you see, what is the IP address here? What is the IP address here? You have the IP address of 192.168.5.100 here. The reason you got the IP address here because you got it from the DHCP server here. Right? You got it from DHCP. So now what I think I put is the 50 here. I change it to 20 here to see what happened here. I have to save here. Okay, save setting here. Save. Why? So now what happened?
I'm assuming the address changes.
Yeah, so basically you can change the address here because you can set it here. ECB here. Yeah, now we're starting from 50, right? Instead of from 100. Because you change it here. You change the range here. So that is some of the basic configuration for the for this one. And do the same when you configure for the home router. Remember, you are able to configure for the network name, you are able to configure for security policy, right? And you are able to configure for password. And remember, when you configure for every cell phone or laptop, you also have to match information with the router here, right? I see that some of you make mistake because you not configure the same network address, you not configure the same password, you not configure the same security here, right? So instead of AES, you set it a TKIP here. Any question for this one? Let me know. Any question? Okay, now the second one. The second one here. So the second one, you work with the kind of the IoT, Internet of Things, or you can think about the smart home, right? You see, nowadays you can control about the light or thermostat or whatever connect to the internet here. So basically, if you have the IP address config for the IoT device here, you're able to control it, right? So now see, you are able to connect it to the access point. You are able to connect it to the access point because you configure everything matching with the wireless here. But think about this one here. You are not able to manage this. You are not able to manage it. You are not able to manage. You are not able to manage all of the device here because you are not connected to the IoT server here. So basically for this one, you have to configure this server as an IoT server, right? So let me open it here. You have to configure the IoT server. So here, some of the I see some of you make mistake here. In the step right here that you have to configure on the server desktop here. You click on IoT monitor, right? You have to enter server IP address that you note in the step 3 here. So see, if I want to check what is the IP address of the server, how can I do it? How can I do it if I want to check what is the IP address of the server here? How can I do it? How can I do it?
Let's see. Click on the server.
Yeah, by the package tracer, right? By the package tracer, you can see here you have 192.168.5.203. Again, this thing you got it from the DHCP server config in the wireless router here. But actually, in the real life, if you want to know it, you have to go to the command prompt, right? You have to go to the command prompt and you check the command here, IP config here. So in that case, you know that, hey, this IP address here, we got it from the DHCP server is 192.168.5.103 here, right? So you have to copy this and you have to configure it in the IoT here. All right. So now you have to change the IP address here. You log in. So you have the username admin. Oh, why? What is username?
In the steps, it says go to sign up now.
Yeah, admin. Okay, so now see, you already configured for the IoT server, right? That's the first thing. But you are not able to control all of the device here, yes, because they are not connected to the server yet, right? So in order to connect it, so you have to go to the IoT server. Sorry, you have to go to the configuration here, right? And you have to enter the IP address of the IoT server. That is the IP address of this one here, right? So that's why here you have to enter, sorry, this one here, you have to enter this one, right? That one here and connect it. Yeah, so now we connect it already. So you see, now it show up, right? It show up here. Also, you do the same this one here. You do the same. This one is not correct. This one it is a default gateway. This one is the default gateway when we go out, not the IoT server here, right? So for this one here, you also have to correct it, connect it. Okay, so now you go back to this one. You have the two devices connected, right? So now device wise device offline here. Oh, I think that you have to what is this? Connect already. 3 presses. Yeah, you already connected here. You already connected here. I don't know why it's a device offline. It's on. Network plus on. Network here on. Discord. Oh, the IP address here is not correct. You will not get the IP address yet, right? That's why you see you have not get the IP address yet here. So you have to refresh it. IP address here, IP address here now correct here. So I'll do it again. Refresh it. Okay, refresh. Question. Something wrong with this one. Anyway, that is the basic step and configure this one. Or if you want to configure, you can do it from the beginning. You can see what's going on here. Alright, so basically that is the one you work with this package tracer here. So basically when you connect it, you can turn on and turn off from this one here. Okay, so any question for this one? Hello?
No, we're good.
No
Okay.
question.
So if you know question here. No question. Let's see what you have. This one. Now I want to review about the last class here. So in the last class, we talk about the redundancy in the layer 2, right? So we see that in order to enhance the ability of the network, and in order to prevent the problem of single point of failure here, you can apply the redundancy in the layer 2, right? So think about you have the let me put this one here. Right. Think about you have the computer, you connect to the gateway, and when you go to destination here, right? So instead of only one single part, you can have one switch over here, you can have one switch over here, and you can go to the router and you go to the destination here. But in the case of redundancy here, you have the problem here. What do you think? What is the problem of the redundancy here? What do you think? What is the problem of the redundancy?
Is this one of those cases where the signal can just loop indefinitely?
In the case of redundancy, you have problem of looping. You see, you have the looping here. So think about if you send out the broadcast message, right? When you send a broadcast message here, remember that the switch, whenever the switch receives the broadcast message, it send it out to everyone, right? It send it out to everyone. So again, you see, the broadcast message is just ping pong forever in the network if you have the loop here, right? So in order to prevent problem of the loop, they use a FTP, right? Sorry, spanning tree protocol, spanning tree protocol, SPT. That is spanning tree protocol, FTP. Spanning tree protocol, right? So the spanning tree protocol is a protocol that is maintained about the network topology, and you do a lot of calculation. So from that, he make a decision that you have to block one of the port here. You have to block one of the port in order to prevent the loop, right? But remember, the blocking status here is only temporary. So you see, if something going wrong with the link here, it will automatically bring up the link here. Okay, so that it is a spanning tree protocol. It helps you in order to prevent the looping problem in the case you use the redundancy here. Okay, now you learn something about the port the switch port security also. Can you tell what is some action you can do with the switch port security here? What is it? What is a switch port security action you can do here? What is it? Now, basically, you just remember that when you have the switch, right? You have multiple ports. You have multiple ports of switch, and every computer, when you connect to the switch, it automatically able to connect to the switch and go to the network here. Because by the default, every port in the switch is in the active status here, right? You see, whenever you work with the packages also, whenever we plug in, it usually you go going up here. So what is the first step here if you want to enhance security for the network? I don't know if you follow me on the class last week or not. Oh, sorry, on Monday or not. I mentioned it clearly already. Now, what is the first step if you want to implement the security for the network with the switching? Remember, for the switch, whenever you plug in the cable, the connection automatically going up here. Right? So what happened here? If you have the bad guy, he just plug in the cable into the switch, and he able to access to the network here. It's not good for the security practice here, right? Agree or not?
Agree.
Okay, so what is the first action? The first action here, you have to shut down any port you not use here, right? So we think about in the switch here, you know for sure this port connect to the one computer use. This port here connect to the one computer use. but another port here is not used, right? So in the case of unused port here, you have to shut it down. You have to shut it down. So you see, if the bad guy here, he able to plug in the port, but he not able to access to the internet or to the network here because the port is shut down. Right? Agree or not?
Yes.
Okay. Now, what is the second one? The first thing is that you have to shut down a new port. What is the second one? If you want to implement the switch port security here, what is the second one? Now the second, remember that the switch, right? The switch able to forward to destination because the switch maintain the MAC address table. The switch maintains the MAC address table. The MAC address table is matching between the MAC address and the port number, right? So you see, what if happen here? It is the bad guy, right? He generates the fake MAC address. He generates the fake MAC address here. So one time it's A, another time it's B, the C, and D, and E, and he send it to the switch. The switch learn it from incoming traffic, right? So he update here: A port number 1, B port number 1, and C port number 1, and very soon he overloaded. Right? So in the case he overloaded again, he send it to everyone. That is huge problem here. Right? So the second one that you have to limit the learning. You have to limit for the MAC address for the specific port only, right? So instead of flooding 1,000 or 10,000 IP address in the port here, you can limit it to number 5 only. For example, number 5, right? So see, if he generates the fake MAC address here, if he send out the number 6, the port will be shut down here, right? That's the second one. You are able to limit the maximum address in the specific port. So if you can set the limit number 5 here. If we generate number 6, the port will be shut down. Yeah? It helps you security here. And the third one, is that you can specify what is the MAC address you are able to connect to the port only. So think about this one. Think about this one. You have the switch here, and you have the port, and you know that this port here connect to the CEO computer, right? And you remember that for each of the specific computer or desktop or device, you only have the unique. You have unique MAC address, right? So now you know that for sure. His laptop here, the MAC address here is A only, right? So you can configure it here. This port here only accept MAC address of A. So now what happened here? If someone try to hijack it, he plug out the computer and he plug in another computer on the port here. You see, when you plug in another computer on the port, the MAC address is not A anymore because A here is unique, right? So that's why the port here also shut down here. Okay, it makes sense or not?
Yeah, it makes sense.
Okay, so basically for the switch port security, you have the 3 ways to do it here. The first one, you shut down every unused port. That's the first thing. The second one, you can limit in the MAC address for the port. And the third one, you can specify what is the MAC address you are allowed to connect to the port here. Okay. So in the case of hierarchy design, you have the 3 layers. You have the access layer, you have the distribution layer, and you have the core layer here. The purpose of that is to enhance the security and enhance the performance for the network here. Okay, so let me close this here. Let's see. You see, you have the 3 layers here, right? You have the access layer, you have distribution layer, and you have the core layer here. Access layer is where you interface with the end device, with the laptop or desktop here. Distribution layer mostly work with the redundancy here. You see, instead of if the link here going down, you still have the another one to go through here. Right? And the third one is the core layer. Core layer is everything interface with the backbone network here. So by basically for the large network, you just break it down into 3 layers here. It helps you in the case of availability and redundancy and performance of the network here. Okay, so you also have the definition about the software design design network. So basically, remember that for each of the device, you have the you have the three function here. Sorry, you have the two major function here. The first one is a control plane, and the second one is the application plane. So we can think about in the street, the control plane is everything when you configure about the remote access, like SSH or Telnet or spanning tree protocol. Everything here is a control information. And if the switch want to route to the destination, it is about the application plane here that he look into the MAC address and he forward it to the destination. So basically, for the software defined network here, you have the dedicated server to control everything about the application. Sorry, control everything about the control plane here. In that, you have the dedicated server. You can set up what is information for the remote access, what is the information for the spanning tree, every control information here. But for everything about the infrastructure plane, it do it locally by the switch here. And also we have the information about storage area network. In that you want to store the network here. So in the case that you have to do with the redundancy, and you have to use the optical cable to interconnect them together here. Okay, and you have the virtual architecture, right? The virtual architecture, that means you have one single physical computer, but on top of that you can install for multiple virtual machines here. And they have definition about the host is the physical computer, and the guest is each of the virtual machine here. So the hypervisor is the one who control about the resources of the virtual machine, right? So we tell how much memory, how much storage, and how much processing be able to do it. And you have the two types, the hypervisor. So the type one here, type one, that means you is the that on top of the hardware, right? So on top of the hardware, and on that, for each of the virtual machine here, you have to install the operating system on that. And the second one, you have the hypervisor on top of the host operating system. The second one is the most common. You can see in the VMware, or you can see in the VirtualBox, right? So we think about if you have the computer with the window here, you can download the VirtualBox and you install the virtual machine with another window or Linux on top of that here. Okay, so remember that when you work with the virtual machine, you have some benefit. You can create a multiple computer here, but of course you have to share memory. You have to compromise memory, right? Memory amount, memory storage, and the processor. And when you work with the virtual network here, you have the network connection type. You have three types. That the first one is the bridge here. Bridge, that's one. Every virtual machine work exactly the same with the physical. It got IP address from the physical DCP server. So that's why you see the IP address here in the range the same with the physical computer, right? And the second one is the network address translation mode. That means you got it. You work as a network interface card from the physical computer here. Work as a bridge, and if you want to go out the internet, you have to translate it to the IP address here. That's why you see the IP address here is not the same. 10 or something. This one 192 here or something. Right? And the third one is the host only mode. Host only mode is in case that you only able to communicate from the another machine to the another one here. You are not able to communicate to the outside network here. And this one is very good in the case you want to do with the isolation network here. Isolate network here. Okay, and of course you have the pro and con of the virtualization. And for the network function virtualization, that means you can do something with the virtual here. You can have the router virtual, you can have a firewall, a virtual firewall, or you can have a virtual router or the firewall or the switch here. So we see, instead of spend a lot of money in the upfront money to buy about the dedicated server, dedicated router or the switch, you have to pay a lot of money. You have to maintain a lot of space to put them, and you have to pay a lot of money for maintain them, right? So now we can do with the virtual. You need one single server, but on top of that, you can have the virtual machine for the router, you can have a virtual machine for the firewall, and so on. And cloud computing, you have the cloud computing, you have the 3 mode, you have the infrastructure as a service. That means you only rent, you only list about the hardware, but on top of that, you have to install the operating system and you have to download the application to do the work. The second one is a platform as a service. That means you rent out the hardware and operating system also. Your operating system, and you are the one who responsible for application here. And the last one is a software as a service. That means you rent everything. You don't have to do anything. Okay, so yes, you have some information about home learning here, and I think if you want to dig it down, you should watch your recording video again. I see that some of you don't care much about the lecture. You just care about the homework. It's a choice, right? But if you want to learn something, you get some knowledge here. It help you with the future work and help you think about in the future career here. At least you have to pay some attention to the lecture. You learn it from the lecture. Now I move to the new lecture here. For today's lecture, it module 8 about the segmentation here. Okay, so just remember that sometimes you have to do with the broadcast message, right? So can you give me some example when you want to do the broadcast message here? Can you give me some example? In what scenario you want to do with the broadcast message? Any idea? You learned it already. What is the broadcast message? What is the broadcast?
Sending to everyone.
Yeah, send it to everyone on the same network. Send it to everyone on the same network. And can you give me the example when you want to send it to everyone on the same network? Give me some example here.
The first example that comes to my mind would be upcoming maintenance on the server. Like you would send that to people to let them know that the server is going to go down for a little bit for maintenance.
Okay, that's good. That's good. Okay, and yeah, right. That's right. And to make it simple here, you already learned something about the ARP already, right? You know what is the ARP? ARP address resolution protocol. And when we use the ARP here, think about this one, right? If you want to send it from the one computer, right? 192 here, 168.1.10, and you want to send it under the one guy here, 192, 168.1.20, right? So see that in the process, you have the whole process of encapsulation, right? So see, if you want to send it from this one to this one here, you have to encapsulation here in the layer 2, layer 3, right? Layer 3, you have the IP address here. IP address here, and you send it down to the layer 2. You have encapsulation, right? So in the layer 2, you have to put it down. What is the destination MAC address? What is the source MAC address here? Now in the case here, this guy here, he want to send it to the 20, right? He want to send it to 20. He knows the IP address, but he don't know the MAC address here, right? He needs a MAC address to do the encapsulation here, but he don't know what is the destination MAC address. So in that case, he have to send out ARP message. ARP message is the broadcast message. You send it to everyone on the same network, and you raise the question: who is .20 here? And if I the .20, send me your MAC address. So see, that is an example of the broadcast here. Remember, the broadcast message is sent to everyone on the same network, and remember that each interface of the router is one network here. So basically, you see, everyone here is the same network. And sometimes they call it the broadcast domain. It's the reason they call it the broadcast domain, because whenever you send out the broadcast message, it's come to everyone here. And remember one thing here, the broadcast message is the router is the one who stops the broadcast message. Router never forward the broadcast message. So sometimes they call it the domain name, right? Now, What do you think? If you have the huge broadcast domain, that means you think about this one here. You have 400 users for this network here. What is the problem of the huge network here? Of the huge network domain here? What do you think? What do you think?
Well, let's see. When you're, I assume it takes a decent amount of effort from the equipment to send it to everybody. And like if you had, I feel like if you had several computers doing this, if it's not handled properly, you could have like a bunch of address resolution protocol messages going around.
Okay. Okay.
Also, can't it potentially take a while to do all the different computers too?
Okay, that's correct. Now the thing here, right? So we think about this one here. You can think about this is a network and connect it to the router here. Think about this network. You have the 400 user here, 400 computer, right? So think about this one. If you have a 400 computer, if one computer here send a broadcast message, so all of the remaining 399 computer, he have to accept it, he have to handle it, and he have to process it here, right? You see, so we see if you have the huge network here, it's that some of them they send the broadcast message. It's a huge problem with the network here. That most of the time you have to handle about the broadcast message. You have to take time to handle it, process it here. That's the first thing. Right? Slow down the performance of the network. The second one is that you see if all of them the broadcast message, right? You consume a lot of bandwidth in the network here. Right, so that is a huge problem with a large broadcast domain here. Right, in that case, you see, slow down the performance of the network and consume a lot of bandwidth here. So basically, in order to mitigate that problem here, you can break it down from the larger network. You can break it down into a smaller network here. So now think about this one here. Think about my network here, right? So at the beginning, I have the 400 user here. Sorry, I have 400 users here. Now I want to break it down into two smaller network, here. So this one I have 200 here, and this one I have 200 here. So what happened here? If one guy from this network here, he send it a broadcast message, right? So see, when he send it a broadcast message, only 199 from the network here, computer on the network here have to handle it and process it. But when you send it to router is the one who stop it here, right? So see, it not impact to the 200 user on the network here, right? So this one is not impacted by the broadcast message from the network here. It makes sense? Hello?
Yeah, it makes sense.
Yeah, it does.
Yeah. Right. So you see, you break it down into two network here. This one, if you send out broadcast message, only 199 of this one impact, but not this one. This guy here, no impact here. Okay. So that is the one reason you want to break it down the network here. Now that is only one reason, right? That's one reason here. Of course, you have many other reasons here. We learn it later here. Now, okay. Now, okay. What is it? Oh, why I don't. So okay. So when a network is a segment into multiple smaller network here, right? So some of the things occur here. The traffic on one network is separate from the another network traffic, and each network is own broadcast domain. Right? So when you work with the segmentation, remember segmentation, that means you break down the larger network into the multiple smaller network here. The first thing, you can enhance security, and talk about why you enhance security later. You can improve the performance. You know that, right? Performance, that means you don't have to handle many broadcast message here, and you consume a lot. Sorry, you can save a lot of bandwidth here. And the third one is simplify the troubleshooting. I see you can narrow down what is a segment you have the problem here, and you can go to the segment you do some activity here instead of a whole huge network here. So in the case of the network segmentation, you can do by the geographic location. I can think about this one. You can break it down. The first floor is one network, second floor is another network, and so on here. Or it can work with the department boundary. So we think about this one here. In this one, is this case here. This is the case you work with the department handle boundary here. Right? So think about this one. You can break it down to that network here into multiple subnetwork based on the department here, right? So see, you can break it down in the administration network, in the human resources network, in the student network, and the accounting network here. So what happened here? If you have a student here, right? He connected to the network, he only able to connect it to the another student in the same network only. He not able to go to the administration network, and he not able to go to the human resources network here. So that help you to enhance the security here, right? Right? Now, back then, if you group them, all of them together in one network, everyone able to communicate together. So student here can look what's going on with the human resource and can look what's going on with the administration here. It's not good for the security here, right? So by segmentation here, you can break it based on department here. So we have the administration, you have the human resources, and you have the student, and you have accounting here. It helps you to enhance the security here. Agree or not?
I agree.
Okay, and the third one is the divide type here. So you can break one network for all of the host here user, one network for all of the printer, or all the network for the server here. So we see it help you to narrow down the problem of troubleshooting. I think about I have problem with the server, I just go to the server network here and I do just troubleshooting instead of the whole huge network here. Okay, so now we know something about the subnet mask. The subnet mask here. Okay, now we know how subnet mask works. So before you learn something about the subnet mask, we have to understand the structure of IP version 4. This is one normally work with IP version 4 here. So let me explain something about the IP version 4 here. So basically for IP version 4, you have 32 bits. You have the 32 bits of IP address, right? And it break it down in the 4 group here. One group 8 bits, another group 8 bit, another group 8 bit, and another group 8 bit here. And one the 8 bit here they call it the octet. Octet, that means you have the 8 bit here. So for the 8 bit here, it can be everything, all of them 0 here, right? Or all of them number 1 here, right? So you see that for the IP address version 4, you have the 32 bit, and it represent by 0 and 1 for 32 bit here, right? But you see, when you represent by 0 and 1 for the 32 bit, it's very hard for you to remember and do the other thing here, right? So basically, to make it simple, they convert into the decimal here. They convert it into the decimal. So if you have the 5 bit of 0, 8 bit of 0, you convert it, you have the 0 here. And you have 8 bit of number 1, you convert it to decimal, you have the 255 here, right? So that's why you see normally for the IP address, you have something about 192.168.1.100 here. You see, that is the 8 bit here. You convert it to decimal. That is the 8 bit, you convert it to decimal. That is the 8 bit, convert it to decimal here. And remember that each of the decimal here only in range from 0 to the 255 only. Right? It makes sense?
Yeah, but
Yeah, what is the but here?
I noticed that maybe I just missed something obvious, but I noticed that like when I'm doing projects, the subnet mask is like always 255, 255, 255.0. I was just wondering why that is.
Okay, now I'm not mentioned about the subnet mask first. I don't say anything about the subnet mask yet. Right now, I just talk about the IP address here. Right? This is the IP address. Remember, the IP address is not the same with the subnet mask. I will explain it later. I explain. Yeah, I know.
Oh, sorry, I got a bit confused.
No, it's okay. I understand the question. It's a good observation here, but I'm talking about it later. So now is that no, it is IP address here. IP address is you have the 32 bit, break it down into 4 group, and each of group, when you convert to decimal, you have everything from 0 to 255 here. Now, again, for this one, for the IP address, again, for the IP address here, it break it down into 2 portions. They call it 2 portions. They call the first one is a network portion, and the second one is a host portion. Right? So it depends on the network. Some of the network here, you have the 20 bits in the network portion, and you have the 12 bit here in the host portion. Remember that when you add them up together, right, you have the 32 bit here. Now, some of the network, you have the 24 bit in the network portion, and you have the 8 bit in the host portion. Right? Now, it depends on the network. And remember one thing here. If you have more bit in the host portion, you have a larger network. If you have less bit in the host portion, you have less network here. Now think about this one here. If I have network of 24 in the network portion, I have 8 bit here in the host portion, and I have another network here, 20 bit in the network portion, and I have the 12 bit here in the host portion. This one here, it's a huge network. It's a larger network because it has the more bit in the host portion when compared to this one. Okay. So right now, we just remember that IP address, you have the 32 bits. Right? You break it down into two portions, network portion and the host portion. And if you have more bit in the host portion, you have larger network here. Now, come with the next idea here.
A real quick question. Is it possible for the other section to get bigger than the network one?
Say again, what is the question?
Is it possible for the network question to be smaller than the other one if the server gets too, I mean, if the size gets too big of the server?
Sorry, I don't get the question here.
Yeah, I'm having a hard time
Okay,
describing it.
okay, you can come back to me later. But I think that after a while for this class here, I think after this today class, you might find the answer for the question. If not, you can come back to me.
All right, thank you.
Okay, so now you just remember that you break it down into two portions. You have network portion and the host portion here. And the question here, how can you tell how many bits belong to the network portion and how many bits here belong to the host portion? So in order to answer that question, they call it the definition of subnet mask here. That is the answer to the question before, right? The subnet mask here, the format of the subnet mask is exactly the same with the IP version 4. The subnet mask also, you have the 32 bits. You have the 32 bit for the subnet mask. The same with the IP address, the same with the IP address here. Right? But the different and the significant information in the subnet map is that you have to remember that it's very important here. In the subnet map, every bit in the network portion, you have number 1, and every bit here in the host portion you have number 0. Right? So now think about this one. If I have network of 8 bit here number 1, 8 bit here number 1. 8 bit here number 1 and 8 bit here number 0 here. That is a subnet mask. So now if you think I have 8 bit here number 1, 8 bit here number 1, 8 bit here number 1, and 8 bit here number 0. So can you tell me how many bits in the network portion I have for this network, and how many bits in the host portion I have for this network here?
It's all together 32 bits, right?
Sorry?
It's all together 32 bits.
Okay.
Right?
Yes. So how many bits in the network portion here? For the subnet mask, this one, how many bits in the network portion you have?
24.
Yes, right. You see, you have the 24 number 1 here. So for this network, you know that you have the 24 bit for the network portion, and 8 bit number 0 here. You have 8 bit for the host portion. That's all. That is the meaning of the subnet mask. So by looking into the subnet mask, you see how big network it is, how large network it is. I remember that the more bit you have in the host portion, you have a larger network. The less bit you have in the network portion, in the host portion, you have the smaller network. Okay. So now again, with the subnet mask also, to make it simple, they convert it to the decimal. You see, so if you have the 8 bit of number 1, you convert it, you have 255 here. 8 bit of number 1, you convert it, you have 255 here. 8 bit number 1, you convert it, you have 255 here. And 8 bit number 0, you convert it, you have 0 here. All right, so we see this network here, actually you have the subnet mask in the decimal, you have 255. dot 255.255.0 here. Right? So I think that it answers the question before, right? You see, why 255.255.0?
Yeah, I do. Thank you.
Yeah, right. Now think about this one. You remember for the subnet mask here. Remember the subnet mask. Okay, it break it down 2 portions, right? Network portion and host portion. And every bit here, number 1. And every bit here, the host number 0. It is a subnet mask. And remember that the more bit in the host portion, you have the larger network, right? Okay, so in the subnet mask, you can represent everything as 0 and 1 at here, or you can put it in the decimal here, 255.255.255.0. That is second one, right? The first one is in the binary. The second one is decimal. The third one you can represent in the slash notation. Slash notation, that means you have slash here. And for this network, you have slash 24. So slash 24, that means you have the 24 bit in the network portion. And of course, when you have slash 24, you only have an 8 bit left in the whole portion here. Right? It makes sense or not?
It makes sense.
Okay, so now just remember for the subnet mask, you have 3 ways to represent it: binary, decimal, or slash notation. Now, if I have a slash network of slash 24 and I have network of slash 26 here, so what do you think? Which network is larger? Which network is larger network?
The one with 24.
Yeah, right. This one here, you have the 8 bit in the hot portion. This one only you have the 6 bit in the hot portion only. So in the case you will learn it later. So in the case you have the 8 bit in the hot portion, you have the 2 raised to the power of 8. You have the network of 256 address. But this one here, you have the 2 raised to the power of 6 is only support for 64 address only. Now that's why this one right here is way bigger than this one. Okay, so now you know the definition of the IP address. You know the definition of the subnet mask here. Now, what else? Let's see. Let's come back. Okay. The subnet mask. You know that what is the subnet mask already, right? The subnet mask is a so. How the subnet mask work? Subnet mask work here. You see, you have every bit in the network portion here. You have the number 1, right? And every bit in the whole portion here, number 0. And you see that is the network ID here. That is network ID. You have the network ID for this one, and the host ID, host portion here. You have 132 here. So now, remember that you have some benefit when you break down the larger network into the smaller network. Right? You see, the first one improves the network performance and save a lot of bandwidth. The second one is that enhance the security here, and the third one is easy for you to do the troubleshooting. Right? Now, you do the subnetting here. So when you work with the subnet, you have the 2 formula you have to remember. You have to remember when you work with the subnet here. You have the 2 formula here. Let me explain this later. I think you need to know something first. So basically, just remember that for the network here. Think about at the original network here, you have the network portion, and it has a whole portion here. So you see, for each network, you can think about you have kind of the rectangle here. You have that is a pool of IP address inside each of the specific network here. So the the segmentation is the process of breaking down in smaller network, right? So you can think about this one here, cut in half. So you break it down into the 2 smaller network, or you cut in 4, you break it down into the 4 smaller network, right? So basically the process of segmentation is a kind when you have a pie and you cut it into the smaller pie piece here, smaller piece here, right? So if you want to break down into the small network, the first process here you have to understand here. If you want to break down in the small network, you have to borrow. You have to borrow from the bit. You have to borrow some bit from the host portion, and you bring it to the network portion here. Right? The first step you have to borrow it. You only have to remember that you have to borrow it here. You have to borrow. You bring some bit from the hot portion and you bring it to the hot portion to the network portion. Sorry. So think about this one here at the beginning. You have bit at the beginning here. You have the 24-bit number one in the subnet mask here. 24-bit number one. And you have 8-bit here, number 0. It's a hot portion here for the subnet mask. Right? So now, if you want to break the network here, remember that you have to borrow some bit from the hot portion. You bring it to the network portion. So think about this one. I want to borrow 1 bit here. I want to borrow 1 bit from the hot portion to the network portion. Remember that in the case you bring from the hot portion to the network portion, the subnet mask change. Right? You see, you borrow 1 bit, you have to change it to the number 1 because the subnet mask now is not it's not /24 anymore, right? So now the subnet mask here is /35. Okay, make sense or not?
Makes sense to me at least.
Okay, so you see at the beginning you have the 24-bit number 1 and 8-bit number 0. Now we want to borrow 1 bit, so that's why you have the /35 here. So remember, when you change the when you borrow some bit here, the subnet mask is not the same. It changed from the 24 to 25. And of course, when you convert it to decimal, this guy here, 255.255.255.0. But now if you have /35, when you convert it, you have 255.255.128 here, not 0 anymore. I will explain it why it's 128 later here. Okay, that is the first thing you have to remember, that if you want to break down small network, you have to borrow bit from the hot portion. You bring it to the network portion here. Now, let me do with the conversion here. So remember for the octet, right? For the octet here, you have the 8 bits. So we have the bit number 0, bit number 1, bit number 2, bit number 3, number 4, number 5, number 6, and number 7 here. And each of the bit, they have the value for this one. All right. So for this one here, you have 2 raised to power of 0, 2 raised to power of 1, 2 raised to power of 2, 2 raised to power of 3, 2 raised to power of 4, 2 raised to power of 5, 6 here, 7 here. So now, 2 raised to 0, you have 1. Z is a column 1. Z is a column 2. Z is a column 4. Z is a column 8. Double 8, 16, 32, 64, and 128 here. Okay, makes sense. All right. So now you see, if I have the bit of number 1 and I have 0, 0, 0, 0, 0, 0, 0 here. When I convert it to decimal, you see, I have 128 here. I have 128. All of them here 0, 0, 0, 0, 0, 0, 0 here. That's why when I convert 1, 0, 0, 0, 0 here into the decimal, I have 128 here. Okay, so that's why if you look in my example here, if I have a 24-bit in the network portion and I have a 8-bit here in the hot portion at the beginning, my subnet mask here 255.255.0. But now if I borrow 1 bit, here, I have 34 here. I have 1 here and I have 7 bit left here. You have all of them 1 here. I have 1 here and 7 bit here in the hot portion. You have 0. You see, when you have 24 bit here, number 1, you convert it. You have 255 here. And the last 8 bit here, I have 1 and all of them 0. I convert it. I have the 128 here. So we see, whenever you break down the network, you borrow some bit from the network portion. From the hot portion. You bring it to the network portion. The subnet mask change. The first thing here, we change from the /24. Now we change to the /25. And when you work with the decimal, it changed from 255.255.255.0. Now it changed to the 255.255.128 here. Okay, it clear or not?
Yes, thank you for explaining that.
Okay. Okay, so now honestly, this class, I think this class it covers too many information, but never go into detail. That's why I try to explain it to you here. So otherwise, very hard for you to understand what's going on with this one. Now, when you work with the subnet here, you have to understand, you have to remember about the two formula. You have to understand about the two formula here. The first one, you have to calculate the number of the subnet. The second one, you have to calculate the number of hosts in each subnet here. So remember, if you want to break down into small network, you have to borrow some bit. You have to borrow some bit, right? So that is the first formula here. If you borrow n bit from host portion, I think about this one, the network here and the host portion here. And if you borrow n bit from the host portion, you bring it to the network portion. In total, you can have the 2 raised to power n subnet. Right? That is the first formula. So that's why I see if you borrow 1 bit here, you are able to break it down into 2 subnet. If you borrow 2 bit here, you are able to break it down into 4 subnet. And if you borrow 3 bit, you are able to break it down into 8 subnet, and so on. Okay, that is the first formula you have to understand here. So now my question here, if I want to break it down into 6 subnet here, so what do you think? If I want to break it down 6 subnet, how many bits I have to borrow? How many bits I have to borrow?
Let's say 6 subnets.
6 subnet. How many bits I have to borrow?
Dang, 1 second. Let me do the math. Sorry.
You can see it here.
Isn't it 64 or
Sorry.
6?
No. I'm asking you that I want to break it down into 6 subnet, not I want to borrow 6 bit here. I want to break it down in 6 subnets.
What do you need?
Bit? Yeah, how many bits I have to borrow?
Would you need to borrow 5?
No, 5 too much. You have the 5, 2 by 5, you have the 32 here. Too many. I only need 6 here. What do you think?
You only need to borrow 2 bits.
2 bits not enough. 2 raised to power 2, you only have 4 subnet here.
Oh,
Not
3. It's
Yeah.
Oh, I
right.
see. It's
Right.
Is it?
Right, 3, right? 3
Okay.
here, right? Because you see, if you borrow 3 bit, you have 2 raised power 3, you have 8, of course, 8 here, able to support for the 6, right? And of course, you can borrow 4. Borrow it again, it's too many here, right? Okay, that is the process here. So I hope you understand the meaning of the first formula here. Remember that in the first formula, if you borrow n bit in total, you have the 2 raised to power n subnet. Right? Now, the second formula here. The second formula here, if I have n bit in the host portion, you think about this one. I have n bit here in the host portion. Sorry, network portion. All right, and now I have the h bit here in the host portion. To make it straightforward, I change it to h here. I change it to h here. All right. So now, if I have the network, I have h bit here in the host portion. So in total, I will just that is second formula here. In total, I can have the 2 raised to power of h, and I minus 2. And the reason that I had to minus 2 because for each network, you have to reserve 1 address for the network address, and you have to reserve 1 address for the broadcast address. That's why you have to minus 2 here. Okay, so now let me give you another example here. All right, now think about this one. Sorry, I clear it here. Now think about this one. I want to break down the network that support for 60 hosts here. Support for 60 hosts here. So what do you think? How many bits in the host portion do I need in order to support for the network of 60 hosts here? How many bits? How many bits do I need? What do you think? The formula here. How many bits do I need in the host portion in order to support for network of 60 hosts here?
Might.
Huh?
Might be wrong, but 2 maybe.
2. Now see, if you have 2, you have 2 raised power of 2. Right? You have 4 here. and you minus 2, you only have the network of the 2 hosts here. How can you support for the 60 here?
Oh, I misunderstood the formula.
Okay, that's the
And we
formula
have
here.
6, right?
Yeah,
6.
right, 6. You need 6. You need 6. The reason is that you have 2 raised to power 6, you have 64, right? And you minus 2, you have 62 here, and 62 here able to support for network of 60 hosts here. It makes sense?
Yeah, now it does.
Okay.
Yeah, I get it.
Okay, so that I just want you to understand the 2 formula here. The first one is how many subnet. The first one here, how many subnet you want. The second one is if you break it down in some smaller network here, each of the subnet they can support for how many hosts here. So basically, in work with the segmentation, you only have to balance between the number of subnet and the number of hosts here. So when you work with the subnet, it's better you work with the magic number. You work with the magic number here. So what is the magic number? Magic number, it is a value of the last number 1 in the subnet mask. So you can look on this one here. This is the IP address, right? This is the IP address here, and this is the subnet mask here. This is the subnet mask here. So now, if you look on this one here, if you look on this one, do you think for the network here, for the subnet here, 255.255.24, and we convert it to this one here, what do you think? What? One more question. Oh yeah, what do you think? For this one, how many hosts you can support for the subnet here, for the network here?
3.
How many hosts? Why 33? Why 33? Yeah, someone give the answer is 33 here. Why? Why? Yeah, 32 is the address, right? So now again, if you look on the subnet mask here, you can see how many bits in the network portion you have. How many bits in the network portion you have for this one? How many bits in the network portion here? Network portion
27.
Yeah, 27, right? 27 here. 27. All right? 27. That is not a 27. You have the 27 in the network portion. And how many bits in the host portion you have? How many bits in the host portion you have? You have 27 bits in the network portion here. So how many
5.
bits? Yeah.
8.
5, right? You have the 5 bits left in the host portion because you see in total you have the 32, right? So when you have the 27 bit in the network portion, you have the 5 bit in the host portion. You can see here 5 bit number 0 here in the host portion, right? Make sense?
Yeah.
Now the question here, if you have the 5 bit here in the host portion, so what do you think? How many hosts this network can support? How many hosts this network can support here?
32.
Yeah, 32. It is address, total address, but now you have to come back. You have to come back to this one here. You have to minus 2, right? You have
Okay,
to
so
minus 2
30.
here. Yeah, one for the network address and one for the broadcast. So basically for this one here, you have formula here, 2 raised to power 5 and minus 2. 2 raised to power 5, you have the 32. And you minus 2, you have the 30 here. So for this network, is able to support for maximum of the 30 hosts only. Right? Now, come back with the definition of the magic number. Come back with the definition of magic number here. So the magic number is only value of the last number 1. Remember that? It's only a value of the last number 1 in the subnet mask here. So if you look on the subnet mask for this one, this is the last number 1, right? This is the last number 1 in the subnet mask. And see, this one here, value 138, right? This value here, value 64, and this value here, 32. So for this one here, for this network with /27 here, or 255.255.224 here, you have magic number of 32 here. It makes sense?
Yes, I think.
Okay, now you have the magic number 32 here. So now how we work with the how we work in subnet here. So basically when you subnet, you break down the large network into multiple subnet, and each of the subnet increased by the step of magic number. Oh, you can see it here. You can, to make it simple here, let me do it here to make it simple. Right. Now to think about, at the beginning, I have the network 192.168.1.0, and this one is /24. Right, the 74, that means I have 24 bit here in the network portion, and I have the 8 bit here in the host portion. Right. So now that is /24. Right. So come back to the example here. I break it down in the smaller network. This one here, I have this one 24, this one 8. Now I break it, I borrow 3 bit, right? So now I have the /27 here, and I have only 5 bit in the whole portion here. All right. So now you see from the network /24 here, I borrow 3 bit. I have a /27. I borrow 3 bit. So what do you think? If I borrow 3 bit, how many subnet I can have? How many subnet I can have here? If I borrow 3 bits, how many subnet? The first formula here.
Let's see.
First formula.
Is it 30?
No? Why 30?
Oh, wrong one. Sorry.
No, I am asking about how many subnet. Not the whole. You have the two definition here, right? The subnet, that means how many pieces. Right? You can think about that. Subnet, that means how many pieces. And the whole, that means how large a bit it is. That think about that. Right? So if I borrow 3 bit here, from the 24, I borrow it, I have a 27. How many subnet if I borrow 3 bit? How many pieces?
Is it 4 or 5?
No. Now come back to the formula here. See, that is the formula here. So if I borrow 3 bit, how many subnet? How many subnet? Formula here, 3 bit here. How many subnet?
8.
8, right?
8.
Because, yeah, 2 raised to power of 3. I have an 8 here. So we can think about this one here. At the beginning, I have the original subnet here. Now I break it down into the 4 and 8 here. Right? And 8 here. That's all. That's the process of that. And for this one, I break it down into the, I borrow 3 bits. That means I can break it down into the 8 subnet here. Right? Now come back to this one. You know that I want to break it down in 8 subnet, right? I want 8 subnet here. So now come back to this one. Yes, this one here. So you see, at the beginning I have /24. Now I borrow 3 bits. Right? I borrow 3 bit here. So now I have the /27. And when you have /27, you have the subnet mask 255, 255, 255, 224 here. Right? The reason 224 because you see, this one is 138. This one is 64, and this one is 32. When you add them together, right? 128 plus 64 plus 32, and all of them 0 here. When you add 128 with the 64 and the 32, you have 224 here. Okay. Now come back to this one. This is an example that I want to break it down into 8 subnet here. Right? That's the first thing. I know that I want to break it down into 8 subnet here. Now the second one, you know that the magic number here is the last number 1. It is a 32. That is a step of subnet network here. So see the first one here, I have 0. Right? I have 0 here. The next one here, I have add it up with the magic number. Add it up with a magic number. I have 32 here, and add it 32. I have 64. Add it. You have this one, this one, this one, and this one, and this one. You see, I have 1, 2, 3, 4, 5, 6, 7, 8 here. Right? So you can think about this one here. You can think about this one. All right. I think that is it. At the beginning here, I have the huge network here, right? So now I break it down into the 8 part for 18, right? So now I see you break it down in 8 part, right? I have the 32 for this one. I have 32 for this one. I have 32 for this one. I have 32 for this one. Sorry, 32, 32, 32, and 32 here. Right? So we see at the beginning, I have the slot 24. Slot 24, that means I have 8 bit in the whole portion. So 8 bit in the whole portion, I have 2 raised to the power of 8. I have 256 address here. Of course, I have to minus 2. Right? So at the beginning, you see, when you add them together, you have the 256 here. 8, right? 32 here, times 8, you have 256. Right? And now I can break it down. I can break it down into 8 small subnet, and each of them 32 address here. Right? And of course, 32 address here, but actually you only able to support for the 30 host only. You have to reserve one for the network and one for the broadcast. Okay, so we can think about this one. It's the same example when you have a huge pie here. You have a huge pie and you cut it into the 8 equal pieces here. Make sense or not?
I think I get it.
Okay. So we see this one here. You see, it only increased by the magic number, right? You have 0 here. Now the next one, you have the 22, you have 32 and 64 and so on here. Okay, so that is a step in the case you work with the IP with the 4 subnet calculation here. The first here, remember that you only have to borrow someone. If you think about break it down in small network here, the first thing only have to borrow here. Now you have to borrow here. Okay, the question here, how many bits you have to borrow? That it depends, right? Depend on the how many subnet you want to break it down. You have to use the first formula here. So you see, if you want to break it down, if you borrow n bit here, in total you have to 2 raised power of subnet here. That's the first step. You have to borrow some bits. The second one, you have to determine the subnet mask here. You see, when you borrow, right? When you borrow the some bits, the subnet mask change. Right? See, if you borrow 3 bits, at the beginning you have the slot 24. Now you have slot 27, and of course this slot 24 here you have 255, 255, 255.0. But this one here you have 255, 255, 255.224 here. All right. Now the next one, you determine what is the magic number. The magic number for this one, you see that example here, you have the 32, right? You have the 32 here. Now you determine the network ID. Network ID is the first, is the network address for each of the small piece of the subnet here. So we see the first one here is 0. The next one you have 32. The next one you have 64 and 96 and so on. It increased by the magic number here. Right? Okay, so the last one is determine the range of the IP address of the host in the subnet here. So we see, I have the one network of 192 here, 168 here, .1.0. That is the first subnet, right? And the second one, I add it up to the magic number. I have 192, 168.1.32 here. That's the second one. And the next one, I have 192, 168.1.64 here. So we see, Z is the network address of the first subnet here, and the one come right before the second one here. It is 192, 168.1.31. They call it this one they call it the network address. This one they call the broadcast address here. Broadcast address. Remember, for every subnet, the network address and the broadcast address, you have to reserve it. You cannot use it aside to the computer, to give it to computer here, right? So everything here, everything between the 192.168.1.1 and come to the 30 here, they call it is the address of the host here. Yeah, it makes sense or not? I see a lot of information here, but I hope you understand it. Otherwise, if anything not clear, let me know.
I think I got most of it down.
Okay, so 0 and 31, 0 network address cannot use for the computer. broadcast address 31 cannot use for the computer, but anything between from 1 to the 30 here, they are usable address or host address here. Okay, so basically, when you work with IPv4, they have the definition of the class 4 address also. Class 4 address is that mean you have the class A and class B and class C here, you for the computer. And if you have the class A, you see, if you have a class A here, you have the 8-bit in the network portion. So yeah, you have the network 8-bit in the network portion, and you have the 24-bit in the whole portion. That's why it support huge network here, because you see you have the 24, right? You see that you have formula here, 2 raised to 24, you minus 2, 1 for the network, 1 for broadcast. That's why it support for this address here. And the class B is support for 65,000, and the class C here, you see that is the most common. You can see, right? You have 192.168.1.0/24. You have 24 bit in the network portion and only 8 bit here in the whole portion. That is support for the 256 address, and of course minus 2, you only have a 254 address for the computer. And class D here is for multicast, and class E reserve here. So you see, the class A you have everything from 0 here to 127, and class B you have everything from 128 to the 191, and the class C you have from the 192 to the 223 here. Okay, so now when you work with subnetting, normally you have the 2 type of question here. You have the 2 type question here. They're given the certain network requirements that require number of port for subnet. You have to figure out the possible subnet and the port IP address range here. So think about this one here. I have the network 192.168.0.1.0/20 here. 20 here. I want to break it down into the 3 subnet. So for the 60, 20 and 60 and the 40 here. Right? So now, sorry, this one is not this one. I think this is 26 here, not 20, not 20. 20 here. Okay, so well, so that's 20. 26 is not enough. And the second one here. The second one, it can give in the IP address and determine the subnet network address. What is the broadcast address? One is the first, and what's the last usable address here. So think about this one here. I have 192.168.1.80, and I have a /26 here. Now you know that for every IP address, you only have a range. The first one is the network address. The last one is the broadcast address. And the one come right after the network address, they are the first usable address. And the one comprising the broadcast address, they are last usable address. So for any IP address in the range here, or any IP address in this range with the subnet mask, you are able to figure out what is the network address, what is the broadcast address, and what is the first usable address, and what is the last usable address here. So to make it very simple here, right? So you see, you have the /26 for this one. You have /26 for this one here. That means you have the 26 bit in the network portion, and you have the 6 bit here in the host portion. Right? So now what do you think? If you have the 26 bit in the network portion and you have the 6 bit in the host portion, what is the magic number for this one? What is the magic number for this one? What is the magic number for this one? What do you think? Remember, the magic number is the value of the last number 1 in the subnet mask. Now we can think about the /26, right? So we have 8 bit here, number 1. 8 bit here, number 1. 16 already, right? 8 bit here, number 1. 24. Now 26, right? So we have 25, 26, and of course I have 6 bit here, number 0. So The magic number is the last number one is the subnet mask here. That is the value of this one. That is
Is
the
it-
value. So what is it? What is the
Is
magic
it
number?
64?
Yeah, right, 64. Because you see, the first one it is 128. Right? The first one is 128, and the second one is 64, and the third one 32, and so on. So now we see the magic number here is 64. You know that, right? The magic number here is 64, and you can now that create here. Oh, why not able to create? Oh, I draw it directly. Sorry. So for this one, you know that the magic here is 64. Right? So basically, it break it down the network in the step of 64. You know that, right? So see, the first one is only 192 here, 192.168.1.0, and you add it up to magic number 64. The next one is 192.168.1.64, and the next one you have the .1.128 here. So we see the NETI here, the NETI here is range from the 64 to the 128, right? So now we know that the 192.168.1.64 here, it is a network address. Makes sense? Or you can
Yeah.
Yeah. Okay. Now let me give you here to easy for you to follow. So 192 here, 192.168.1.80, right? /26. And you know that the magic number here, if we get out 64 already, right? So see, now at the beginning here, you have /24. You can think about this one. You have class C here, you have the /24. Sorry. At the beginning here, you have /24. Now you have the /26. So what do you think? How many bits you borrow? How many bits you borrow here?
Is that borrowing 2 bits?
Yeah, you borrow 2 bits. So you borrow 2 bits, how many subnet you can have? Borrow 2 bits, how many subnet you have?
Is
First formula here.
is it 4, or do I have the wrong one again?
Yeah, 4, right? The first formula is that if you borrow n with the formula here, 2 raised to the power of n. So here you have 2 raised to the power of 2, you have 4, right? So now you can think about this one. You know that you want to break it down into 4 equal subnet here. Now, so if you look on this one, the first network address of this network here, 192.168.1.0. That is the first one, right? So now you know that you can think about this one is 0 here, right? And the magic number here is a 64. So the next one here, 192.168.1.64. That's why you have 64 here. The next one, you add it to the 64, you have 192.168.1.128 here. You have 128 here. And the next one, the last one, you have 192 here. 192 here. All right. So see, you break it down into 4 equal subnet. This one here, this guy here, come everything from 0 to 63 already. All right. And this guy here, come everything from 64 to 127. This guy here, come everything from 128 to 191. And this guy here, come everything from 192 to 255 here. All right. So now, if you look, sorry, if you look on the NETI here, it in the range of this one, this one, this one, or this one. What do you think? NETI here in the range of?
It's in the 64 to 127 range.
That's all, right? You can clearly see it. So now you see the NETI here in the range from this one, right? So now, if you have 192.168.1.80, you know that 64 here is a network address, and 127 here is a broadcast address, and of course everything between the 65 and 126 they are usable address, or they call it the host address. Is it okay? Make sense?
Yes. Thank you.
Okay. Good. Okay, so for this one, you see, for this one here, you have the /27. That means you borrow 3 bits, right? At the beginning here, you can see at the beginning you have the /24. Now you have /27. You borrow 3 bits, and that's why you have 2 raised to the power 3. You have 8 subnet here. You're able to support the 8 subnet. And if you know that the /27, the magic number here is 32, right? 32. That's why you see you have the network here, right? 98.0 is the first one, right? 32 here is the second one, and the 64 here is the third one. And of course, 0, 32, and 64, they are network address. You cannot use it. So that's why you can use the number 1 here is the first one. And 32 here is the second one here, and the 65 here, and so on. Okay, so we see you can break it down into, you can break it down from the large network here. Now you can break it down in smaller network. Right? You have a lot of benefit for us. So basically, that one of the reasons you want to break it down, right? One of the reasons you want to break it down into a small network, because you want to have a smaller broadcast domain. Right? I see you want to break down it. You have a smaller broadcast domain. So if every one of the computers send it out broadcast message, not everyone is receiving it here. Only contained in the smaller broadcast domain. Right? But the thing is that when you work with subnet mask here, you have to pay attention for the DHCP. DHCP is a dynamic port configuration protocol. That means you can get the IP address automatically from the DHCP server here. Right? So basically, the DHCP server, they work with everything about the DORA. You just remember about the process you remember the process of the DHCP. They call is a DORA. D here, that means discover. Right? The first one, you have the discover here. Right? The O here, you have the offer. O here is offer. Right? And R, you have the request. You have the request. And A here, A, that means you have acknowledgement here. So basically, that you just think about you bring your laptop or cell phone into the Starbucks. They have the wireless or free wireless, the Wi-Fi here, right? So see, if you want to go to the internet, you need the IP address, right? So the first thing, you go to the network here. You don't know who is the DHCP IP address, right? That's why you send out the discover message. Discover message. It sent out to everyone because you have no idea. You are a new member here. You have no idea who is the DHCP server, right? So we send it out to everyone. That is broadcast message. Discover here is a broadcast message sent out to everyone, and you raise the question, who is the DHCP server, right? So the DHCP server received the discover message here. He checked it in his IP address pool here. A lot of IP address, and some of them is occupied, and some of them is available here. So he pick anyone available. He replied to you. Right? How about 192.168.1.10? Right? So that is he sent you with the offer, right? So when you receive the offer with 192.168.1.10, he send it out here. Request, yeah. Now I accept it. I accept 192.168.1.10. And again, this one broadcast is send it out to let every other one computer knows that from now on I will take 192.168.10.10 here. Right? And the last step here is acknowledgement here. So now this IP address here, he mark it not available anymore. Right? Now you give it to the computer here. So the process is a DORA, but the thing is that you have to use the broadcast message here. Right? You see, you have to use the broadcast message here, and you have to use the broadcast message here. So what happened here in the network, right? In the network here, you can break it down into the smaller network here. One network, and one network here. You see, you have multiple networks, but you only have one single dedicated DHCP server only. And this one here is not on the same network as this one, not on the same network as this one, not on the same network as this one, and not on the same network as this one. Remember that each interface of the router is one network here. Now we see this server here is not on the same network with the PC1, right? So now what happened here? This guy wants to get the IP address, right? he have to send a broadcast message. So see, when he send it to broadcast message, by the default, router is the one who stop the broadcast message, right? The router is the one who stop the broadcast message by the default. So we see he send out discover message and the router drop it, and he have no way to get the IP address. So in that case, you have to configure the DHCP relay. DHCP relay that you have to configure on the router to tell router that whenever you receive the discover message, send it from computer, please forward it to the DHCP server here. Okay, and after that you can get the IP address here. Otherwise, you will not drop it because the router is the one who stopped the broadcast message here. Make sense? That is the clear exception here, right? So when we send the discover message, you have to configure in the router and tell the router that whenever you receive the discover message, please forward it to the DHCP server here. Do not drop it. Make sense?
Yes, thank you.
Okay.
Yes.
Okay, so now, so far we know that. So far we know that all we learned so far the code it is the code so far the code it is fixed length subnet mask. 6 length subnet mask, you see that means you break it down equally, right? You break it down equally. So think about this one here. You break it down equally. So at the beginning you have the /24 network. Now when you break it down equally into the 4 network, you have the /26 here, right? So this one here, /26 network, /26 network, /26 network, and /26 network. They are equal in size. That's why they call fixed here. Everyone 26, 26, 26, 26. They are equal in either side here. Okay, but when we work the fixed length subnet mask here, you have huge problem. What do you think? What is a problem with the fixed length subnet mask here? What do you think? Any idea? Any idea?
Could you repeat the question? I didn't catch it. Sorry.
Okay, so when you break down the network equally here, it's the fixed length subnet mask here. Fixed length subnet mask here. What is the problem of the fixed length subnet mask? What is the problem when you break it down equally here? What do you think? Nah. Okay, you don't have to answer it. Just remember my question here. I just come back to the slide here to show you. So if you look on the zip topology here, remember that each interface router is one network. So if you look on the topology, for this one, what do you think? How many subnet you have for this topology? How many subnet you have for this topology?
I would assume 4 groups.
Now remember, each interface of the router is one subnet. So how many subnet you have? How many subnet you have?
4?
No. So see, you have a 1, 2, 3, 4, and see, each interface of the router is one subnet. So we have 5, you have 6, and you have 7 here.
Oh,
Right?
I see now.
Yeah, okay. Now, remember, you have the 7 subnet here. And for this subnet here, they call it the point-to-point connection. Point-to-point connection, that means you only need one address for the one point here, and you only need one address for the point here. Right? For the 2 end, one end, one address, and another end, another address. So basically, for this network here, or for 3 of the network here, you only need 2 usable address. Right? But the thing here, what happened here when you break it down equally? You see, at the beginning you have the /24, right? Now you have to break it down in the 7 subnet. Now think about, if you want to break it down into the 7 subnet, how many bits you have to borrow? How many bits you have to borrow if you want to break it down into the 7 subnet?
Would that be 3 bits?
Yeah, right. 3 bits. 3 bits. Okay. Okay, so you have the 3 bit here because you have 2 raised to the power 3. You have 8 here, right? So see, now you know that you have to break down equally into the 8 subnet, right? So see, when you put 3 bit here, you break it down in the slash 27, right? Because see, from the slash 24, you borrow 3 bit, you have the slash 27. So if you have slash 27, how many bit in the hot portion you have? How many bit in the hot portion you have? 27 bit in the network portion. How many bit in the hot portion you have?
5.
Yeah,
5.
you have 5 left, right? And now second formula here. If you have a 5 left in the hot portion, how many hot address you can have? How many hot address you can have?
Would that be
formula.
32?
Yeah, you have 2 raised to the power 5, but remember you have to minus 2 here, right? One network and one broadcast, so basically 30 here, right? So now you see that you are able to break it down into 8 equal subnet. Each of them support for maximum of 30 here. So we see this one 50, 25 is okay, right? This one 20 is okay, less than 30 here. 50 is okay, 28 is okay. This one only 2 and 2 here. So we see you are able to do it, right? Break it down into 8 equal subnet here. So you can take one for the one, take another one for the one, take another one for the one, and so on here. You can use 7 of them, and you can reserve one here. You can reserve available here. But that is a huge problem here. You see, for the network here, you only need the 2 address only, but you have to reserve 30 for that. That's why for each of them, you wasting the 28 here. Totally wasting. You cannot use it for anything. Right? So we see in total here for the 3 subnet here, you waste about the 84 address here. It's huge waiting here. And if you think about, if you work with the public IP address, every IP address you have to pay money for that. You have to list it from the internet service provider here. So that it is a problem of fixed length subnet mask here. Right? The fixed length subnet mask here. If you break it down equally, agree or not? Agree or not?
Yeah, I agree.
Yeah, you see, you wasting here. Instead of only need 2 here, you have to use the 30. Each of them you waiting 28 here. So you see, huge waiting here. All right. So now that is only the simple example here. Now think about this one. Now another huge problem with the fixed length here. What happened here? I need this one here. I need the network support for the 40 here, not the 25. Not 25 anymore. I cannot do it. Right? I cannot do it because the thing here, when I break it down in the 8 subnet, each of them only support for 30 here. I cannot support for the 40 here. Right? I have no way. So see, that is also a huge problem when working with the fixed length subnet. Even that you have many IP address here, but when you break it down equally, you cannot do it. Right?
Yeah.
Okay, that is a huge problem with the fixed length subnet mask here. So that's why they come up with the idea of the variable length subnet mask here. Variable length subnet mask, that means you cut it but not equally. So think about this one. I want to break it down into I have a pie here. I want to break it down into the 4 subnet, but I don't want to break it equal. Right? I'm very hungry. I have the big half here. Right? So my wife, the second one, and 2 my boy here. So you see, my here, 1 here, 2 here, 3 here, 4 here. I can break it down unequally. That is the case of variable length subnet mask here. And in the case you work with the variable length subnet mask, you can save a lot of IP address. Okay. So for this class, normally everything is a definition only, so I don't want to go into detail with, right? I don't want to go into detail for that one. But you see, in the case if working with the variable length subnet mask here, right? You break it down, right? You break it down in the 4 ABC here for the LAN, right? And you can break it down furthermore for the WAN here, and you can save a lot of IP address when you work with the variable length subnet mask here. Okay, so now it is IP subnet into IPv6. This chapter very long. This chapter very long here. Actually, it's not long in the text in the textbook, but if I stick to the textbook only, I can sure that you cannot catch up here. That's why I try to explain it to you to have more idea when work the homework here. Otherwise, very challenging here. Okay, now for the subnet in the IPv6. IPv6 is not the same with IPv4. IPv4, you only have the 32 bits in the IP address, and in the IPv6 you have 128 bits here. Right? The reason they come with the IPv4 because they come with the IPv6 because IPv4 run out of the IP address. See, you have the 32 bit here, so we have 2 raised to the power 32. You have about 4 billion. It's not enough for today. That's why they work with the IPv6 here. The IPv6 you have 128 bit, huge range of the IP address here. Okay, so basically in the IPv6, they break it down into 2 portions. Right? There you have the network prefix and you have the interface ID. You can think about the same with IPv4. You have the network portion and the whole portion here. And in the network prefix here, normally you got it 48 bit here. You got 48 bit from the internet service provider. Right? And the next 16 bit here, it is a subnet ID. That means you can take it, right? You can take it and you can give it to every subnet you want to break it in here, right? So you see, if you have the 16 bit in the subnet here, so basically you have 2 raised to power 16, you have about 65,000 subnet. Yeah, you can very flexible with that. You can break it down into many subnet here. Okay, so for the subnet in the IPv6, it's very simple. It's very simple when it works IPv6 here. So we can think about this one here. Everyone here, you have to stick to that. It is a prefix ID. And you got it from ISP. Everyone is the same. Everyone the same. But this one here is a 16 bit. 16 bits. That means you have 4 hexadigit. Because in the IPv6, it works with the hexadigit, not the binary here. So you see 4 digit here. Actually, it is the 4 hexadigit. And each of the hexadigit you have 4 bits. So actually for the 4 hexadigit here, you have 16 bits. And for the IPv6, it's very simple. You see, you can change this one is 0, and the next one is the 1, and the next one is 2, and 4, and so on here. You have huge way to work with the subnet in the IPv6. So you can see, you can assign this one here for the first subnet, the 2 here, the second one, 3 here, the third one, 4 here for the fourth, and 5th, 5 here for 5th. Or you can do with A, B, C, D, and E here. It doesn't matter, provided that they are not the same. We do not work with IPv6 much, so I don't go into detail here about idea of that. Okay, now we see for this one here. If a server has the subnet mask of 254, how many bits in the IP address identify the host portion? Or make it to make it simple. If you have 254 subnet mask, how many bits in host portion you have? What do you think? How many bits in the host portion you have for this one?
Could it be 5?
Yeah, right. It's very simple here, right? You see, 255 here, that means you have 8 bit number 1, right? 255 here, you have 8 bit number 1. 255 here, you have 8 bit number 1. Now 24. This one 128, right? This one is 64. You add them up together, you have 192. And this one, you have the 32. You add them up together, you have the 224. And of course, you have 50 here. So see, you have the 27-bit number 1, and you have the 5-bit here number 0. That is the whole portion here. Now the correct answer is this one. Now we go with the virtual LAN here, So what is the virtual LAN? Virtual LAN, it is group of port on the switch, so that some of the local traffic on the switch is a port to go to the router. Right? So basically, by the default, remember that by the default, every port on the switch, they are on the same network. They're on the same network, and that is the VLAN number one. VLAN number one. Right? By the default, every port on the switch, they are on the same network, and the VLAN number one here. So basically, if you have the switch here and you connect it a computer together, is that connect computer together, and when you configure the IP address of the computer on the same network range, you can communicate directly together to anyone because they're on the same network here. Right? So let me is simple here. That goes simulation here. Let me go back. Okay, so by the default, you see, by the default, if we look on this one here, by the default, here, you see, this one here, everyone here on the same network, right? Because they share the same gateway, they connected to the same default gateway of the router here. Everyone here on the same network. Everyone here on the same network. Everyone here on the same network, right? So if you look on the street here, by the default, everyone is belong to the same VLAN. Let me change the form here so we can see more thing. So I will show VLAN repeat. So you can see for this one here, you see this one here by the default, every port of the switch, they belong to the same VLAN, VLAN number one, and you can see from the port number 1 to the 24 here, everyone belong to the same VLAN. And when you have the same VLAN, that means you are able to communicate together, directly together. You don't need to involve the router here. So right now you can see I can ping, I can ping from number 10 to the number 20 here. So you see, I can ping it normally. I can ping it normally here. Okay, so by the default, remember every port on the switch of the same VLAN, and if you configure on the same network address here, 192.168.1 and 192.168.1, 192.168.1, 192.168.1, everyone able to communicate together here. So now to enhance the security, you can think about break it down into the VLAN. So what is a VLAN? VLAN, that means virtual, right? V, that means virtual. LAN, that is local area network. You can think about this one here. You can think about this one. I want to group these two computers together, and this guy here, it belongs to the HR department, human resources. And I want to group this one here. I want to group this guy here together, and this guy here, it belongs to, I can put it here. This guy belongs to the student here. So I want to make sure that the only computer is student here able to communicate together. He have no way to go to the HR, and from the HR also, from the HR he only able to connect to the other computer on the HR. He have no way to connect to the student here. Right? So in that case, you see, physically all of them belong to the same network here. Physically all of them connect to the same router, the same network, but logically I can break it down into the multiple. I can break it out into multiple virtual network here. Right? So now for this one here, I have the VLAN. I have this one is F0/1 and F0/4. Right? I want to convert it here. So see if I do it here. F0/4. Now I set VLAN number that I have to create it here. So I think I cannot do it from here, but I have to do it from the switch here. I just create the VLAN number 10, VLAN number 20, and sorry, VLAN number 10, and put its name here. Name here. I put name HR here. Now VLAN, I see this. I have VLAN 20, and name is student here. So now I show VLAN right here. So right now we see. Right now I already create the VLAN number 10 for the HR and the VLAN 20 for student, right? But I have not associated port to that yet, right? So see, right now all the port still belong to VLAN 1, right? So next step here, I have to assign the port here F0/1 to the VLAN HR and the port F0/4 here to the VLAN HR here, right? So I have to go to the interface /1 support and I can do the same with the number 4 here. Okay, so now I check it again. So now I see, you see, I already have the port number 1 and the 4 belong to the HR VLAN. Now I can do the same. I can do the same. The port number 2 and 3 go to the student with the VLAN 20 here. 2 20 here. I can do the same with number 3. Okay, now I check it again. So now you see the port number 1 and number 4, 1 here, 4 here, right? Belong to the HR, that VLAN HR. And the port number 2 and 3 here belong to the student here. So now you see what happened here. If I am able to ping from the HR here to the student or not, right? I can do it again. I bring it here. I put it ping here. Now what happened here? Yeah, you have no way to deliver it, right? You have no way to deliver it. That you only able to bring it to the same network only. So let me come back to the main tab here. Now let's do it again. Ping 192.168.1.20. It is a student guy here. So from HR here 192.168.1.10, I am not able to bring it. I have no way to bring it because right now I configure on the different network here. See, I'm no way to bring it here. Okay, so we do the same with this guy here, 30 here, 30 here also student. You have no way to bring it. Okay, but now what happened if I bring it to the 40 here? 40 is this guy here. This guy here is on the same VLAN, HR or VLAN 10 here. I'm able to bring it. I'm able to bring it the same. So see from this guy also, this guy here, he have no way to bring to the 10 or the 40 here. He have no way to bring 40 here. Have no way to bring the 40, but he able to bring to the 30 here because they are on the same VLAN here. Now set 30 perfectly. So make sense to you? I think that the simulation here might help, right?
Yeah, I think it helped a lot.
Yeah. So that is the process of the VLAN. So remember one thing here, by the default, the switch only maintain one VLAN only. It's a VLAN number one by the default, and every port is belong to VLAN number one. So that's why at the beginning you are able to communicate together, right? But now if you want to break it down in VLAN, that means virtual VLAN, you have to configure VLAN into switch, and you have to assign specific port to the VLAN here. Okay, so that is a process of VLAN. So we see it's very flexible, right? It's very flexible here. So what thing about this one here? Now this guy here working in manufacturer, user config on the switch and assign to the manufacturer. But if he promote it or he change it to the admin, sorry. But if he promote and he go to the administrative instance here, you can easily configure it on the switch here. You don't have to run cable again. You don't have to do anything again. You just do some simple configuration in the switch only, right? You just assign to the port to the specific VLAN only. So you see, you have a lot of benefit when you're working with the VLAN here. Enhanced security, and it's very flexible here, right? So now think about this one here. Think about this one. Let me give you an example again. Now think about this one. This one here now, now think about 40 here. He's not HI anymore, and he become the student here. Right? So in that case, you don't have to run cable again. You just go to the switch. You just go to the switch here, and go to the port F0/4 here. Right? So instead of VLAN 10, now you configure it to VLAN 20 here. Instead of VLAN 10, now we configure it to VLAN 20 here, right? So now, actually, this guy here now belong to the student already, and you have no way to bring it to him to the 40 here. Right? So you see, you can bring the 40 here. At the beginning, you can bring it 40 here, but right now you are not able to bring it because not on the same VLAN here. And of course, this guy now able to bring it. This guy now. This guy now able to bring it here. Yeah, see, it's totally flexible. You don't have to run cable again. It's just very simple configuration in the switch away. So any questions so far? Any question? Hello?
I'm good here.
Okay. So you see that is the way you configure for the VLAN. You go to the switch, you create the VLAN, and you assign the port to the VLAN here. You assign port to the VLAN. Oh, what happened? Let me see what happened with this one. Okay, so for the switch port configuration, you see, you can flexible, right? You can assign, you could create the VLAN and you assign the port to to the specific VLAN. And of course, you can flexible here. One time it can be VLAN 10, and another time you can VLAN 20. Totally flexible, right? And you don't have to next together. Even that the port here 30 and the port here 30, it doesn't matter. It's totally flexible here. Okay, all right. So remember that by working the VLAN, you can have enhance the security here, right? And remember that for the inter VLAN here, whenever you want to do with communication or inter VLAN, you have to involve the router here. Okay, so now we have the definition about the access port and the chunk port. The access port is where you connect to the end device. You connect to the computer, the printer, or laptop here. And the chunk port is the one who interconnects the switch to the switch or the switch to the router here. Right? Remember that the access port belong to only one VLAN. But the chunk port, when you interconnect the switch together, it belong to the many VLAN here. Right? So that is something you have the definition of that one. Right? So you see now. This is the access port, right? It only belong to VLAN 1 or VLAN 2 or VLAN 1 or 3 only. That is access port. But when you interconnect the switch together or you interconnect from the switch to router, they call it the chunk port. The chunk port here is the one who carry for, by the default, it carry from any VLAN, for every VLAN. So with this one also, it carry for the VLAN 1, 2, and 3 also, right? That is some definition also you have to remember about this one. And VLAN and subnet. So basically, when you work with the VLAN, normally also you work with the subnet here, right? So you break it down into HR department, it's one subnet, student department, it's one subnet here, and so on. Right? See, it's a VLAN. Okay, and you have some type VLAN, you have default VLAN. It conflict on the switch. That is a VLAN number 1 here. And native VLAN also is a VLAN number 1. And data VLAN, it carries the user generate traffic, email, web browser, or database. You have management VLAN that when you configure for the remote access or anything with the control information here. So by default, the management VLAN also number 1. The voice VLAN is a support for voice over IP traffic. You know that voice over IP traffic, it is a very latency sensitive, right? So normally you have to set higher priority, you have to set higher quality of service here. So if the congestion going on, you have the priority to go first here. And you have the private VLAN also. Okay, how to configure it? I already give it already. You can have the dynamic VLAN, or you can have the static here. So I think I can talk about the troubleshoot and the CQ VLAN on. Let's see if I have it here. No, I don't have it here. Okay, so I can talk about the double tagging and the switch to spoofing later when working with the troubleshooting the VLAN on Monday here. So, any question? Let me know. I think it's today a lot of information here. So I strongly recommend you that if you are not able to catch up, you watch the recording video again, and anything is not clear, you can just raise a question to me. You can join my office hour, or you can add me on the class. You have a lot.
I have a quick question.
Yes.
Are we meeting on Monday? Because I know it's President's Day.
You have a class on Monday. I don't have any information that we have no class on Monday. Let me see. Let me see. Let me check it again.
Yeah, I just heard that it's President's Day, so I was just wondering.
I think we have class on
Yeah,
President's Day.
Yeah, I think so. Yeah, I don't see.
Okay, I just wasn't sure. This is my first year here, so I didn't know.
Yeah, same here. I checked the Ivy Tech event schedule though, and I didn't think I saw anything listed for President's Day.
No, nothing. Yeah. So we still have a class normally. Okay. We still have class normally. Okay. So
Okay, that's fine.
let's see what we have the homework here. This one already done. Right? Yeah. This one here. This one it already is a secure switchboard. You did it on Monday already. This one. Okay, this one is a subnet. This one is a subnet. Yeah, the subnet here is very, very important here. The subnet, you know the idea of the magic number is very helpful for you to work with the subnet here. And the VLAN also. What is a subnet here? Subnet. This is a simulation. So I don't think you have to do it. So you just follow the instruction here. Oh, all of them is simulation. Oh, the subnet I think is in the part 2 here, not today. Okay, so not much. Now I see you guys on Monday. If you have any question, let me know.
Yep. Thank you for your time today. I feel like today's lesson was pretty good.
Yeah, thank you.
Yeah, today's lesson was pretty good. I might come by for your office hours to talk about the subnetting. That was kind of confusing for me.
Oh, you are totally welcome. You can join my office hour from Thursday and or Tuesday from 9 to 8 to 11 a.m.
Okay.
And you can
Okay.
find information in the syllabus here. Yeah, you can join this.
Okay.
Okay. I'll see you guys on Monday. Bye bye.
Okay. Bye.